Okay, so this video is looking at the re-expression practice that we would do after Chapter 10. So right now we're looking at the worksheet. We're looking at time, distance, and experimental free fall of an object. So we have how much time and the distance it's traveling. And that's the data set we're going to look at. And throughout this problem, this is looking very similar to what you would have to do in our test. You are not going to have to determine the re-expressions. It is going to tell you which transformations you should be doing on the data set. So just make sure you're staying organized. You remember what lists are being plugged in where, what list has functions worked with it. And if you stay organized, you should be able to move quickly through these transformations, call up your scatter plots, find your R and R squared. And I'm going to be doing all this while looking at the calculator. So I'm on a full screen, my calculator, and have that worksheet out with you so you can follow along and have the answer so you can see how I'm getting my work. So I have it in L1 and L2. I have the time in L1, the distance in L2. And the first thing you need to do is call up the original scatter plot, the residual plot, and your R and R squared. Now, the order I usually go through with this, I usually call up my R and R squared first. This is going to take care of the residual. So I have L1, L2, go down to calculate, and there's the equation with your slope and y-intercept, and there's my R and R squared. So you can see 0.972 for the R squared, 0.98, that would round to 0.986 for the R. Now I'm going to do so we're going to have some fairly strong correlation here, so a very strong relationship. When I go to the stat plot, keep hitting double hit in there, sorry. Now I have to make sure that I want the original scatter plot first, so L1 and L2, and I'm always going to zoom 9. And there is our original scatter plot. So you can see it's fairly straight, a little curve in there, nothing major, but a little curve. And now I'm going to do my residual to see if it looks okay there. Now for the L1 staying the same, you want to go to second list, and 7 is my residual. Might be different in your calculator, but it still should be RESID. And again, zoom 9. And there we have a big shape there. We have the U shape, which is not good, positive, then all negative, then all positive again. So the residual really is going to hold this back, even with the high R and R squared. A pretty good looking scatter plot. This residual hurts a little bit. So now we're going to do some transformation. The first transformation is asking for the reciprocal of the distance. So it's the reciprocal of the Y variable. 1 divided by L2 store L3. And make sure you're jotting this down. What list we have that you're putting this reciprocal into. Okay, so we know the reciprocal is now going to be an L3. And I'm going through the same exact work, so I'm going to move a little quicker this time. This time switch it to L3, L1 versus L3. Go down, calculate. And there is my R and R squared. Both are dropping. So this already, I'm thinking this is not good, that it dropped that much. Not that it dropped a little bit, but it dropped a lot. So that's really not going to probably fix that residual. Don't stop, though. Keep doing the original scatter plot and the residual plot so you can compare that with what our original data was. Okay, switching that to L3, zoom 9, and you can see the original scatter plot. The direction, I don't mind so much that changed direction. We had a positive, now it's a negative scatter plot, but the curve is much bigger now. Okay, and that's what really should worry you, is that the curve is that much bigger. And now that we did the residual, the lin-reg once, our new residual is with the transformation data set. So L1 residual, zoom 9, and again, not a good looking shape. We have the 1 point all the way up here, pretty good curve there. So again, this overall transformation did not work out very well at all. That was the reciprocal of the y function. Okay, that was reciprocal of the y function. So the next one I'm going to try is the square root of the y function. So square root L2, I'm going to store this one in the L4 this time. Okay, and again, I'm going to move a little quicker now. Make sure you're using L4. Calc 8, L4, and enter. Okay, there's some pretty good R and R squares there. 0.9956, 0.9978 for the R, so that's looking good. We should be happy with that. Go to our plot. Again, make sure you're using L4, zoom 9. That's very straight, so that's looking pretty good. Let's do the residual. Zoom 9. And that's looking better. Besides that little fella down there, that's exactly what we're trying to look. If you can even just ignore that guy down there, you can see a nice horizontal, no real pattern. You can't see there's no shape to it. This is a pretty good looking residual, minus that one little point, which I'm not saying we shouldn't be concerned with it. We definitely should be concerned with it. But overall, this is a very good residual. So right now, I'm thinking this is a good transformation. This was the square root of the y. Now I'm going to do the square root of the x. So square root L1. I'm going to do this. I'm going to put this into L5. And again, I'm jotting all this down so I remember what list all my transformations are put into. Stat. Now, I wanted to do, I'm looking at number 4 now, square root of time and the distance. I'm looking at the original y variable. So I'm going to do L5, and I'm switching this back to L2. Okay, so that's the original y variable that we looked at. And again, we have some fairly high R and R squares. Not quite as high as our original values, but let's finish up and see what the scatter plot looks like. Okay, so original scatter plot, we're going to have L5 and L2. Okay, so there's our square root of the x. There's our original y value. And we have a little bit of a curve. It's very similar to our first scatter plot that we had, that little slight curve. Let's look at the residual. Okay, so L5 staying the same, put in the residual in there. Residual always goes into the Y list, and we have that big U shape, so that's no good. Okay, so this was interesting. The scatter plot looked very similar, and the residual looked very similar. It did drop the R and R squared a little bit. Now the last one, the last transformation on this worksheet should be the square root of time and the square root of distance. Okay, so we already have those in there. Okay, if you have this, if you kept everything straight and you watched where you put things, you should have already had the 2 square roots in there. So I'm going to go right to my calculation. Okay, because you don't have to do this. I had the square root of L5. I'm going to put this as square root of 4. So there's where the square root of the x variable, square root of the y variable. Go down to calculate. Okay, we have 0.98965, 0.99, so that's fairly high R and R squares. Okay, so there's pretty good looking. I'm pretty happy with that. Not quite as high as transformation just the square root of y variable, but pretty good. Let's look at the scatter plots, because the scatter plots are better looking, then we might want to still go with that, even though it doesn't have quite as high as R and R squared. Hey, that's a pretty good scatter plot too. That would be a judgment call. I think maybe the transformation for just the square root of y might be a little straighter than that one. This might have had just the very slightest curve, but that's a pretty good original scatter plot. Now I go do my residual plot. This is going to be the last thing I'm going to judge off of. And that's where this one's lacking. I'm seeing, okay, this one has definitely more of a curve to it. We have positive values, negative values, and then it kind of swings back up positive. It does have that one negative, but definitely a little more of a pattern than before. So if I'm looking at this one, the next question, the last question, of all the transformations in the original data sets, which fits the linear model the best? I'm going to most likely go with my time versus the square root of distance. That was my transformation for number 3. And again, if you look at R and R squared, it has the highest, it had the straightest original scatter plot, and it had the most random residual. Okay, so if I was judging those, that's probably the one I would pick. But there's, so you can see on the calculator, know that you need to have R, R squared, the scatter plot, and the residual plot are the 4 things that we are going to be comparing to determine which model is the best for our linear function.